What's up, pre-calculus students? Let's go through the multiple choice calculator questions. One thing you're going to notice right off the bat, the calculator part of the multiple choice test, you won't be using your calculator on all the problems. You will have problems where the calculator won't help you at all, and then the problems that you have to do with your calculator. A lot of the questions on the no calculator part, if you had a calculator, you could kind of like graph and investigate and be able to like figure out a lot of the problems without knowing the conceptual answers. You will never see those questions on the calculator part. But on the calculator part, you won't be using your calculator on every single question. So like here we go, number one. Water pours into the container until it is full. Water begins to pour in the container at a constant rate. The depth of the water in the container increases at an increasing rate for a period of time. Then the depth of water increases at a decreasing rate. So it's like the depth is what we're kind of plotting. Let's look at what the depth of water would be constant for a period of time. Oh, okay, no. The water is being poured in at a constant rate. The depth of the water increases at an increasing rate and then increases at a decreasing rate. So it's going to look like that. So we're talking about slowly increasing depth to faster increase of depth to slower increase of depth. It's really between D and C. We could see wider means the depth would increase slower. Narrower would mean the depth increases faster to wider. Let's see. Calculator didn't help you on that one. All of these questions we're about to do, understanding the shape, just reviewing this. We talked about it on the last homework video. If a function is increasing, it is going up. That means the rates of f are positive. If a function is concave up, it could be concave up decreasing or concave up increasing. That means the rates of f are increasing. If f is positive, that means it is above the x-axis. We have no idea what the rates are doing there. Let me pause the video. I have a student in the classroom. You know what's really funny about what just happened? I literally went through what I'm just discussing with the student that came in because they were looking at the table question and like we had x values 1, 2, 3, 4. We had f values that are like 8, 5, 0, negative 10. And the question was like, what's going on with the graph? I said, these rates of change are negative and decreasing. And he's like, no, they're increasing. That's not true. Negative 3 to negative 5 is minus 2. Negative 5 to negative 10 is minus 5. If your rates are decreasing, you are concave down with your graph. 8 to 5 to 0 to negative 10 is concave down. So we got to get this in our brains, guys. We got to get it in our brains that it's not an absolute value. It's the values. 0 to 1, decreasing concave down. Sweet, past water, skydiving. The distance that he falls, total distance fallen. This is increases at an increasing rate, increases at a decreasing rate. Five to 7. Here it is, guys. I mean, here's what I see. The graph is decreasing concave down, decreasing concave up, decreasing concave down. It looks like the graph of f is decreasing concave up. What does that mean about the rates? The rates of change, the slopes, are negative and increasing. Decreasing concave down, the rates of change are negative and increasing. This is decreasing at an increasing rate. You're like, oh, but it's getting slower. No. The slopes are increasing, -5, -4, -3, -2, -1. The values, the rates of change, are negative and increasing. 0 to 2. Same thing. Decreasing, well, this is decreasing concave up. Is that the same thing? So that's the graph, which means the rates are negative and increasing. But they don't say rates. There's no rates. What is the graph? Above the x-axis, decreasing concave up. That means the graph is positive and decreasing and concave up. The graph is positive and decreasing. If it was rates, the rates of G are negative and increasing. So important. How many points of inflection do we have? Well, we can see concave up, concave down, concave up. Points of inflection are when we like change concavity. So it looks like right around here and probably right around here. 2 points of inflection. 7, 8. Man, I gave you bad. I mean, I wish we had one where it was like decreasing at a decreasing rate. This is decreasing at a decreasing rate. This is a decreasing at an increasing rate. This is the same. The rates of change are negative and increasing. It's the same examples as what we just did. This exact same example. But the graph of G is decreasing, concave up. That means the rates of change are negative and increasing. So G is decreasing at an increasing rate. The graph of J is increasing, concave down. That means the rates of J are positive and decreasing. Positive 5, 4, 3, 2, 1, concave down means decreasing rates. So we are increasing at a decreasing rate. Same thing. And we're talking about the rates of change. So the graph of G is decreasing, concave up. Where's the decreasing concave down, people? That means the rates of G are negative and increasing. Hey, there it is. The graph of M is negative because it's below the x-axis. I'm just going to do all of it. M is negative. M is decreasing. M is concave down. The rates of M being negative, being below the x-axis, you don't know anything. Knowing that M is decreasing knows that the slopes must be negative. Knowing that we're concave down means the slopes must be decreasing. Okay, we got it. We are looking at the rates of change of M. The rates of change of M are negative and decreasing. Finally, decreasing concave down. I bet you some of you got all of those previous 10 questions wrong. Rate of change increasing. If the rates are increasing, your graph is going to be concave up. Concave up, concave up. F and, oh, this is concave up too. F, P, and R. What is the rate of change the least? This is so important. Being the least does not mean closest to zero. Being the least means like the most negative. -8 is less than 0. -8 is less than 0. So if I compare those two things, -8 is the least. Positive, negative, more negative, because our rates are decreasing, we are concave down. So positive slopes, zero slope, negative slopes, more negative slopes, because we are concave down, our rates are decreasing. And then our rates start to increase until we get a slope of 0 at D. So C is going to be the least because it's the most negative. Cubic, concave up, concave down, 1 point reflection. Peace.